I'm Buddy Morgan, amateur call WB4OMG. I've been a technical specialist in the West Central Florida section since the West Central Florida section was formed.
Yep.
And how many years ago has that been now, Daryl? It's
About 26
yeah,
years.
26 years. So I've been a technical specialist the whole time. And I mostly deal with VHF and above. Also one of my specialties seems to be running down interference complaints. I do that occasionally. Probably not as often as I should be doing it, but whenever anybody calls me, I do it. Anyway, I live in Lakeland. I'm vice president of the Lakeland Amateur Radio Club. This is an introduction to microwaves. I'm primarily going to be talking about weak signal applications for the microwave bands. I will mention briefly data transmission, wideband digital, and FM, but mostly I'm going to be talking about weak signal operations. So I just used a new term. What is weak signal? Weak signal operations is using single sideband CW and narrowband digital on the bands above 2 meters. And by narrowband digital, I mean WSJT. I assume everybody here is familiar with FT8. See a show of hands? Okay. We use some of the other screens that are available in the software besides FT8, and we'll be talking about that. Weak signal work is mostly terrestrial, but does include EME and meteor scatter operations. And most of my comments will be about terrestrial communications. In the past, microwaves were considered to be the frequencies above 3,000 megahertz or 3 gigahertz. Now the official definition seems to be 300 to 3,000 gigahertz. Really, most people consider microwaves anything above 432 megahertz. That seems to be the definition that most hams have. By the way, anytime you got a question, stop me. I'm probably not going to take up the full hour. Probably everybody want to go to lunch early anyway, but anyway, you got any questions, stop me. Anyway, I'm going to be talking about the bands above 70 centimeters. One common characteristic about the bands above 432 megahertz is there's almost no impulse noise or static crashes. I think I heard power line noise one time on 1296. One fellow heard a static crash on 24 gigahertz some years ago. He was so involved in making a contact that he didn't notice that there was a thunderstorm bearing down on him. And as somebody put it, if you hear a static crash on 24 gigahertz, the next one gets you. I mean, that's just how close it's got to be. I thought I heard some power line noise on 5760 one time, but it turned out it was coming in through the 10-meter IF. But if you ever do hear power line noise on 1296 or a band above that, take cover because there's something on a power pole nearby that is about to explode. We share all of these bands with other services, mostly government radar, and there is interference on just about all of these bands. Well, I'll talk about that as we go up the bands here in a little bit, but I remember back when I first got on 2 meters back in 1973, you'd occasionally hear an intermod. There just wasn't any interference on VHF back then. Everybody's worried about foreign broadcast on 40 meters then, and that situation has certainly changed. There is no known ionospheric propagation on any of these bands. You can get sporadic E has been noticed as high as 432 megahertz, but you get to 900 megahertz and it's all going to be tropospheric propagation. As you go up in frequency, you need to be more concerned with frequency stabilization. You can go buy a radio out of the box from HRO and put it on 75 meters and you're going to be right on frequency and it'll stay that way for years. That's not the case when you start going up in frequency. Even as high as 6 meters, you probably will never notice a problem with being off frequency. It starts kind of on 2 meters, and the higher you go in frequency, the worse it gets. And GPS stabilization is something that's certainly desirable, and the higher you go, the more desirable it is. I'm GPS locked on all the bands 2 meters and up, and if you work another station's GPS locked, I've been within 1 hertz on 10 gigahertz. So you can get quite accurate. Also timing, if you're using digital, you need to have quite accurate time. But you can't talk very far on these bands, right? Everybody knows that. You've heard that all the time. When I first got into the two-way radio business back in the early 70s, I was told you talk further on low band than you can high band, and 450 isn't good for anything. So everybody knows that. That's because what's on the screen right now. Every time you double frequency, you lose 6 dB of signal. That's, you've seen that formula. It's in the ARRL handbook. It's everywhere. The only problem is that frequency, that the formula that we've all used for all these years takes into account the changing size of an isotropic antenna. Yes, if you are on 2 meters and go to 440, if you're using a quarter wave whip on your car and a quarter wave ground plane on the repeater, yeah, you're going to lose some signal when you go from 2 meters to 440. But the reason that's the statement on the previous slide is misleading is as you go up in frequency, antenna sizes, as long as you maintain the same antenna size, you're going to have the same signal strength. That's why a 440 repeater works about as well as a 2 meter repeater. You got probably a 20-foot antenna on the repeater on 440 and 2 meters, and the mobile whips are about the same length. The statement on the previous slide does take into account the changing size of an isotropic antenna. This is the real equation. That's the inverse square law. There's no frequency component. It was first noticed by Sir Isaac Newton back in, when did I say, 1785? But really it's a physical law. This was something that was established by God at the beginning of time. Now there are other losses that go up with frequency, but free space loss does not. So let's talk about some of the bands. 902 megahertz, 33 centimeters. I have used FM on that band. There used to be a repeater in Lakeland on 902, and it worked about like 440. Dave, you used to work that repeater, didn't you? Yeah, it worked about like 440, didn't it? Yeah, pretty much. Nobody noticed a whole lot of difference. For weak signal work, it's going to be a little different than the lower bands. You can get on 2 meters, you can put up a loop 20 feet off the ground, run 50 or 100 watts, and you can pretty well talk around the peninsula of Florida with it on 2 meters. You're not going to do that on 900. Obstructions are more of an obstruction. Your antenna needs to be clear of the trees, and you're going to have a lot more feed line loss. LMR 400 has about 4 dB per 100 feet on 902 versus about 2.5 dB on 2 meters. So it's just a little more difficult. 900, the amount of interference on 900 is absolutely incredible. You've got beeps and bops from telemetry, you've got buzzes from cell phone towers. The spectrum, if you look at the spectrum analyzer, there's just something on there all the time. So you really need to be frequency agile. Most of the time the call frequency is relatively clear, and the frequencies that we use for digital is relatively clear. But if you have something in your neighborhood that's on the frequency you want to use, you're going to have to leave for 2 reasons. Number one, he's probably running a lot more power than you are, and number 2, we are secondary on the band. It's just 900 it's probably the worst band for interference. One guy's theory, he doesn't know where all this stuff comes from, but his theory is that a lot of the interference is from aliens. He's probably right. You can't buy a radio for 900, not for a single sideband or CW or narrowband digital. You can buy FM radios, DMR, I assume NXDN, whatever, but you can't buy a radio for single sideband. So you're going to need a transverter. If this were an amateur radio club, I would go into a little bit of a talk about what a transverter is, but since this is a technical conference, I'm going to assume everybody knows a transverter is something that takes a lower frequency and converts it up to a higher frequency. And well, you can go the other way. But anyway, most of the people that are on 902 use transverters. Matter of fact, they all use transverters. And the usual IF is 144 megahertz. IC705, which is what I use, it makes a great IF. 705 is a great radio if you haven't ever been around one. Very easy to keep on frequency. They're a good radio. You can buy power amplifiers and commercial Yagis at pretty reasonable prices on 902. I mean, there's stuff out there that's 300 watts that you can get for a couple of $100. A lot of it's powered by 24 or 28 volts. You can buy commercial Yagis for 902. You buy stuff at Hamfest. Loop Yagis work better than linear Yagis. I'm going to show you a picture of a loop Yagi here in a minute. It's not a real active band. It's not an international band. I think we have it here in the United States. Pretty sure Canada has it. I don't think there are any other countries that have it. I think it's a citizens band over in Japan, for example. So it's not a real active band. Here in the state of Florida, there's, I don't know, probably about a dozen people on 902 here in the state of Florida. And the calling frequency is 902.1. I mentioned a loop Yagi. That is a loop Yagi. It's just like a linear Yagi, but the elements are circular instead of linear. If you read all the propaganda about them, it's not really propaganda, but they are supposedly more forgiving than a linear Yagi, easier to design. There's just something about them, though, as you go up in frequency, they just seem to work better. And nobody really knows why. You look at it and say, well, that loop, it's somewhat circularly polarized. No, it isn't. It's got a little ellipticity to it, but not a great deal. It's that antenna on the screen is set up for horizontal polarization. It's pretty well horizontally polarized. You can turn the antenna like that, and you can tell that it is pretty hard. It is pretty linearly polarized. There's just something about it that they just work better, and I'm not sure why. Maybe it's a little bit of ellipticity, maybe the fact that it's a linear Yagi is more critical to design, but I've had both on 902 and 1296, and I just find that a loop Yagi works a lot better, and I don't know if anybody's ever found anything any different from that. 1296. Very little non-amateur stations on there. When we get a band opening out to the west, I hear some radar that I understand is coming from the Dallas-Fort Worth airport. But there's very little non-amateur signals on that band. We do not have an exclusive allocation there. There is radar on it, but just very little interference. You can get on there with an IC9700 or an IC905. It'll get you on with 10 watts. And that's probably about the standard 1296 station around here. There are a few of us that have power amps, but most people are running 10 watts. Or you can buy a transverter. Kuhn, Down East Microwave, SG Labs over in Bulgaria will sell you one. Previous speaker mentioned transverters. He mentioned Ukraine. The Ukrainians made some transverters. They weren't half bad, the later ones that they made. And I bought one of the last ones. I bought a 222 megahertz transverter. I think the guy shipped it the day before the Russians moved in. And nobody knows what's happened to the guy. I think the guy's name was Dimitri. Nobody knows what's happened to him. Really a shame. Here again, loop Yagis work better than linear Yagis. There are broadband dishes that are available. You can buy them off Amazon. You can buy one from a fellow down in Miami. His name is Raul. I can't think of his call sign. I can't even think of the name of his company. He doesn't sell direct. You have to buy it through a dealer. But there are some dishes, broadband dishes you can buy that'll work between 800 megahertz and 6 gigahertz. They have others that cover higher in frequency. And they're not half bad. They really aren't. They got a pretty fair amount of wind loading, but they're not half bad antennas, and they're not expensive either. D-Star FM, D-Star Digital Data, all of those work well on 1296. I had an FM repeater in St. Petersburg on 1296 back a good many years ago. I've had a D-Star repeater on 1296, and they all work pretty well. Get a band opening if you got your IC 9700 or your IC 905, 10 watts and a decent antenna up above the trees. You can talk to Texas during a band opening, or you can talk pretty well up the coast. It works well. I think the longest I've ever talked has been probably somebody well up in New England. I think I probably talked 1,200 miles on that band. GPS frequency stabilization is a very good idea, especially if you have an IC 9700. 9700s, when they first came out, they just drifted all over the place. It was a very poor design. They put the oscillator in a place that was close to the power amplifier, and you start transmitting, the radio would start moving. And after about 5 or 10 minutes, it was stabilized. You could watch it on the scope. The radio would go this way and then back that way and then kind of stabilize down. But it really didn't work well. The guy on the other end had to be using his RIT if you were on sideband or CW. Digital would handle it, but still just wasn't a good idea. They modified it where the oscillator would sync with a external 10 megahertz signal, and they got it down to where it would sync like every 10 seconds, and that did a fairly good job. But the best way to do a 9700 is what's called a Bodner board. You take a 49 megahertz signal, which is the signal of the internal oscillator in the 9700, and you inject a signal, an external signal in there. It swamps the oscillator and stabilizes it, and you can work another GPS stabilized IC 9700 on 1296, and you will be right on frequency. You will be within 1 or 2 hertz of each other. That's how good it is. Say with a loop Yagi above the trees, you can work around the peninsula of Florida pretty well. That's a pretty accurate statement. You can talk around. Dave, you've talked to Jacksonville, haven't you? Thought you'd work Jason up there. Okay, or Buzz one. Anyway, there's Dave's on. Anybody else here on 1296? Mark. Anyway, you can talk around pretty well on 1296. It's not going to be as easy as 2 meters.
Yeah, it says up there easiest for EME. Is there any particular frequency that people go to for EME? I mean, is there something like a couple of frequencies or?
Yeah, and the answer is it changes from day to day. I could get Don, WA3RGQ, who lives over in Lake Wales. He's a big EME person. And one of the things I was going to talk about a little later was some of the digital stuff. And he sent me a whole bunch of screens of EME contacts he'd made, and he's all over the place. You just pick a frequency. You try and stay out of people's way. Most of us down below 1296.1. There's down there, but I saw one of his. He was on 1296.200. So, but that is the easiest band for EME. You can get like a 10-foot dish with a circular feed, and tracking the moon is about akin to tracking satellites that you just heard of. You can do it manually. You don't have to have the software, but it's the easiest band for it. You can run. You need probably. Well, there are guys now doing it with 100 watts. Digital has made it a lot easier. Back in the CW days, you needed a little bit more power than that. There are people who make single sideband QSOs on 1296. It's the easiest band. You start going down in frequency. You start your aluminum requirements start getting bigger. Your antennas are much bigger. If you look at a 2-meter EME array, it's massive. You start going up in frequency. Things just get more difficult as you go up in frequency. So it's the easiest band. Power is expensive. It's not a band that there's land mobile service surplus equipment available for, so you're going to be paying for an amplifier more than what you would be for 900 or 2304. So power is going to be expensive. 1296.1 is the calling frequency. 2304, 13 centimeters, lots of interference. That band is incredible with interference. There's not as many Wi-Fi networks on there as there used to be. I used to ride up and down US 98 in my car and just go from one Wi-Fi network to another. It's not that bad anymore, but there's all kinds of other stuff. I think Cirrus satellite radio, they have a kind of a terrestrial fill-in frequency. That's up above the where we operate, but all this stuff runs such high power, it'll overload your front end. And radios like the IC905, that they made them to be broadband, they're particularly susceptible to it. And I use a transverter. I've got a filter that I can pretty well filter out the cell phone tower, which is about a mile from my house. I can pretty well filter it out, but it's still, there's a lot of interference on there. Most of it from cell phone towers. Some of it, Lord knows where it comes from, but there's a lot of interference there. And it's funny, there's one fellow up in Jacksonville that this band N5760, he only runs 2 watts. And he's in an area where there's just so much interference. He usually gives me the same signal report as I give him because of the interference. So, anyway, an IC905 or a transverter, the 2 ways to get on this band. The 905 has made this a lot more popular band. They really have. You can get on there. You've only got 2 watts. Yes, you can put a power amp on the end of it. I've built several of them for people. Got one at home right now that I'm building. But a 905 is, let me see, we've got, how many we got in the state of Florida now? We probably got, I'm just counting, I think we probably have 8 IC905s in the state of Florida now. There are quite a few of them around. Less activity than 1296. Here again, loop Yagis are the best antennas. Now your antenna patterns are starting to get pretty sharp. My 2304 loop Yagi is 12 feet long, something like that. And you're now to the point where if you've got a Yaesu rotor like I am, I haven't bit the bullet and bought the green heron controller yet, but you know, you kind of like that to the button and you may be off the station. Mike K4VJ over in Claremont, he's got the green heron controller, works a lot better. And you're not going to talk quite as far as you will on 1296. I've worked, well, to me, I can work Texas without a problem on there. My problem is when I go up to the next band working Texas. But you're just not going to talk quite as far as you can on 1296. An interesting thing is that if you want to try and work mobile, single sideband just will not work when you're in motion. The multipathing on there just makes it one massive distortion. Now, Dave and I have worked, and Mark works 2-meter sideband mobile a lot. You can notice a little bit of distortion when you're driving around, correct? You just hear a little rough edge to it. It's hardly noticeable, but it doesn't sound quite as good as FM. You go up to 432, you got a little bit more of it. I've never worked 1296 mobile, but I have attempted to work somebody on 2304 mobile. You pull away from the traffic light, and it's so you can't even talk to the guy. Yeah.
I had it happen on 1296, buddy.
Yeah.
Yeah, there was a lot of
It just turns into solid distortion.
Yeah, it's distortion on 1296.
Whereas FM or D-Star or any of the other digital voice modes, they all just work fine. But single sideband, it just doesn't work.
It was unexpected, I'll tell you.
The first time it happened to me, I was talking to Don, WA3RGQ. He'd been up, I think, to Sugarloaf Mountain. He said, "Let me see if I can talk to you on the way down." I don't know what he had for an antenna. And he starts in motion, and it just becomes, just really, really interesting is about all I can say. Okay, I just said it, D-Star works fine, FM works fine. I really should have brought it over here today, but I do have I work 2305.0 FM simplex. I use a circularly polarized skew planar antenna that I bought off of, I don't think I got it off Amazon, but I bought it from a model airplane site. It's about that big. I screw it onto the transverter. I mount the transverter, magnetically mount it on the roof of my car, and then run a piece of RG174 into a FM handy-talkie. And my wife and I use that as a mobile to base channel. We've talked 27 miles with it. I mean, that's essentially, you can talk as far with that as you can with a 2-meter handy-talkie with a quarter-wave whip on the roof of your car. But it's kind of neat. Now, the only real drawback to it is that if you are close together, then you have to be moving the antenna quite frequently. 2 or 3 miles away, you don't have to. But you get out to like 5 or 10 miles, and if the vehicle is moving, then you have to pretty well track it. But it is kind of neat to do that. I guess I've always liked doing things that nobody else can do, and I think I'm one of the few people that does that. There were a lot of 13-centimeter repeaters out in California some years ago. They all got ran off due to Wi-Fi. Wasn't that the Wi-Fi was interfering with them that much, but they were interfering with the Wi-Fi, and they allowed themselves to be intimidated and leave. I think if I'd been there, I'd said, "Show me the license to operate your Wi-Fi network." And none of them, of course, had that. And I would say, "Here's the license to operate my repeater." But anyway, they all left. There have been some other cases, things like that. Anyway, I can work Jacksonville anytime I want. Jason, K4JMX up there, I can work him. It's just anytime. Same thing with Eloy, W4ERP down in Miami. Doug up in Inman, South Carolina. He can hear me just about all the time, but he has an IC905 and does not have a power amp on it. Now, I have one sitting in my workbench right now. It's probably going to go to him. But he can hear me. I'm running 100 watts. He can be decoding me at about a -17, and I have to be coming into him at about a -8 before I can hear him. Back in July of 2025, the big beautiful bill passed. That was Donald Trump's budget bill, and had all kinds of interesting things in there. And one of the things was that the FCC was mandated to auction off 600 megahertz of spectrum between 1300 megahertz and 10 gigahertz, and they had to do it within 3 years. This band falls under that category. I think it's probably almost a dead certainty we're going to lose this band. We lost, I'll get to 3400 here in a minute, but we lost 3456 a few years ago. It was, quote, sunsetted, end quote, as the FCC put it. And I think we're probably going to lose this band. It may not happen in 3 years. The FCC, you haven't noticed, they tend to screw around about things. They probably won't get to it in the 3-year time frame. It'll probably be 4 years. Probably after that, they'll fool around a couple of years deciding what they want to do. So I would say within 5 to 6 years, we're going to probably lose this band. And it's a shame because it's a lot of fun. There's stuff, supposedly we have exclusive access to 2300 and 2310, and that is just not happening. It doesn't really make a whole hill of beans difference because all that stuff that's up above there is running so much power that it just absolutely overloads the front ends. At least it does my equipment and everybody else I know. And it's all there, and I don't see it getting any better. And like I say, we're probably going to lose all of this anyway. It's rather entertaining to hook up a wideband antenna to a spectrum analyzer these days. It really is. There was another question? Okay, 3400 megahertz propagation is pretty similar to 2304. Loop Yankees are the best antennas. You'll need a transverter. It's almost no activity. It was never a really active band, but it used to be 3456. Now it's 3400. We lost 3456 to the radar altimeter people, and we got 3400 in return. And this was kind of, the analogy was like when we lost 220 to 222 megahertz. That pretty well killed the 222 band. It's never recovered from that. And anyway, and we're almost certain to lose this band under the big beautiful bill. 5760. I have the first statement, it takes some dedication. Things just get harder as you go up in frequency, and 5760 is a lot harder than 2304 or 3400. You're going to be using a dish. My first slide there showed my array at home. I use what's called a barbecue grill dish, made by Laird. That used to be Cushcraft. You can buy them in various sizes. And I use a barbecue grill dish because it has relatively low wind loading. Feed line loss is a huge problem. You run into something called the TE1 mode. You can't use any cable bigger than 7/8 inch heliacs. So you're going to have a lot of losses. Or you can buy an IC905 and mount it up at the antenna. Waveguide is feasible. I've kind of looked into that. You have to have a dehumidifier, this, that, and the other. And I may do it, assuming we keep the band, I might do it someday. Interference is a huge problem. You look at the scope, and there's just all kinds of stuff there. Buzzes. Some of it comes and goes. Most of it just stays. Fortunately, the frequencies I use, there's nothing on them. At least not for very long. One fellow down in Miami, he lives in a condo. I think he's on the 18th floor. He puts his antennas out on the balcony. You think, man, that's a great setup for VHF. He's staring right into a forest of towers. I rode by there with him one day, and it's just towers everywhere, and all of them have got stuff on microwave frequencies. So interference is a huge problem on that band. Rain scatter contacts this is the band where rain scatter becomes feasible. And there is a website you can go to called rainscatter.org, I think it is. And if you can find a thunderstorm between you and the other guy, you can make some contacts. I've worked South Carolina and Miami via rain scatter during the summertime. Let's see, I don't know if we're ever going to get any rain here again, though. That's just one problem. Anyway. Contacts are more difficult in 2304. I have used D-Star, FM, and television. And D-Star, DD, and FM all work pretty well. Television, that's a great television band. You got lots of bandwidth up there. The only problem is when you start talking television, you either have to be very close together or you need some power. I've tried sending television to Mike over in Claremont. That's a 35-mile path, and I can't make it even running 100 watts on that band. I'd really like to do something with it, but it's just, you need some power. I regularly make 150-mile contacts on that band. Mike over in Claremont worked Al Ward, W5LUA in Allen, Texas, 930-mile path with 200 milliwatts into the antenna. He had so much feed line loss, it was unreal. He disconnected the coax and the SWR didn't change. I mean, just the coax just made a perfect 50 ohm load. And Mike and I also use it for rag chew. We just get on 5760.1, just sit there and chat away. If you want to have a conversation non-encrypted, it's pretty well private, that's a good band to do it on. You got two narrow beam width antennas pointed at each other. There's not too many people going to hear you. Anyway, the call frequency is 5760.1, and this is another great band that we're probably going to lose. 10 gigahertz. It's a little more difficult than 5760. You will need a transverter or an IC905. I do have a 905, which I use in my Rover setup. It works very well. And feed line loss is an absolute killer. I think I have got between my, I got a preamp and a power amplifier, and I think I've got 18 inches of 1/4 inch heliax, which that's about as big as you can use on that band. And I think I've got about a dB loss in it. So you really have to have your antenna and your radio mounted close. Most people here in the state of Florida operate portable. A few people have EME setups that do pretty well with. If you got a 10-foot dish and a couple hundred watts on 10 gigahertz, even if your dish is mounted at ground level, it will get through the trees. Which trees, my statement there, trees are death on 10 gigahertz, they are. You aren't going to talk through an oak tree very well. That's why most people operate portable. I go over to Lake Parker, there at Lakeland, and I do a lot of operating from there. I can get to the south end of the lake and talk north, or the north end of the lake and talk south. That way I've got a nice path over the lake. Works pretty well. Terrestrial DX record was about 1,000 miles. It was set between W5LUA out in EM13 and K0VXM over in EL98 in Merritt Island. It was about 1,000 miles, and that was on single sideband some years ago. Calling frequency is 10368.1, and there are 10 gigahertz D-Star repeaters in Japan. Several of us have kind of lusted after that, saying, boy, that would really be a neat thing to build, would be a 10 gigahertz repeater, but the expense of it is, it's pretty high, and I don't think we'll ever do it. I don't know where we'd put it, and not enough people to amortize the cost of it. 24 gigahertz, it is considerably more difficult than 10 gigahertz. Signals are weak. I think there's two guys here in Florida fooling with it. And the terrestrial DX record is only 337 miles, so that gives you an idea of how much more difficult it is. 47 gigahertz and up, I think one person had 47 gigahertz gear, and he hasn't been heard from in quite a while. And you can make line of sight plus a little bit, and that's about it. And there is activity all the way up well over 100 gigahertz. I was out at a conference here a few months ago, and there are people up, 135 gigahertz, places like that. There is chips available that'll work. How far you can talk, I don't know. On the bands 902 and above, just about all of our communications nowadays is using WSJT Q65. That's one of those other modes on the FT8 screen. Q65 has been around since 2021. It gave us a more sensitive and versatile mode to operate. It uses a 65-tone frequency shift keying, builds on the demonstrated weak signal strengths of QRA64, which I would never use that. With Q65, and I'm not kidding about this, you can easily complete a contact with a station that you cannot hear out of the speaker or see on the waterfall. It's amazing. And it's actually been improved since you could do that from day one. They've actually improved it. I consistently make QSOs that you can just kind of see some specks on the waterfall. You can't hear anything out of the speaker, especially on the microwave bands. You're probably hearing some interference. Q65 supplemented FT8. It didn't do away with it. Takes up more bandwidth than FT8. Your timing has to be better. I use BKT time sync, and it's better if you use a GPS to sync your computer time rather than a network time server, because the network time server actually has got some latency involved. And it's not quite as user-friendly as FT8. There's to say there's some initial frustration is kind of an understatement, but it's just not. You can download FT8 and get it set up on your radio and get on to make a contact right away. Q65 isn't going to be quite that well, and it's not the big free-for-all that FT8 is. You can look on 40 or 80 meters. You got 20, maybe 40 stations on there. Big free-for-all. Can't quite do that with Q65. It was really designed for prearranged EME contacts. That's what it was designed for. We use it kind of like FT8 with quite a bit of success, but it really was not designed for that. And we use 15-second sequences, mode A, I'll get to that in a minute. And on all the bands, the frequency is 0.170 megahertz. So that is 2 meters, it's 144.170, and 432 would be 432.170. Modes are referred to by Q65 with the time sequence and the mode. So mode A with a 30-second TR sequence would be Q65 30A. There are recommended modes and sequence lengths for various types of contacts in the documentation on the website, and some of it's even true. Most of it, we've kind of learned what works through the University of Hard Knocks. Almost all terrestrial contacts are mode A. Mode C works better for rain scatter. Okay, I got pictures of the screens up here, but you can't really see that much. The waterfall, when you download the WSJT software, you're going to want to set the waterfall to Q65 sync. You've got some new controls that FT8 doesn't have: FTOL, max drift, submode, SH, and TR. And if on the WSJT software, you've got a menu item called configurations. I set up a separate configuration for Q65 so I don't have to change all this stuff. You can't really see it, but that's the Q65 waterfall screen. The waterfall, it's going to look entirely different from FT8. And then the down part, the spectrum analyzer part's where you see the spike. That's what you look for, is the spike. That's the center frequency of the That's actually the lowest frequency of the Q65 signal. And there again, you can't see a whole lot, but that's showing the screen set up for Q65. I should have had one with some contacts on it, and I just didn't do it. We have 5 different time sequences, 15, 30, 60, 120, and 300 seconds, 5 modes, and the bandwidth can vary from 433 hertz to 1733 hertz, versus FT8 is, I think it's supposed to be 50 hertz. I think it's really about 67. So you can't get as many stations in the passband. You got some controls, FTOL, which controls the width of the green cursor on the waterfall, which that's how wide it will look for the signals. That's not quite as important in the newer versions as it used to be. Something called max drift, you leave that at 0. SH, don't check it. I won't go into all that, but anyway. And then sub mode, which is which Q65 mode you want to operate, and then TR, which is the time sequence you want to operate. Now, I'm going over all this at warp speed. If you're interested, bring up your WSJT software and take a look at it. On the microwave bands, Q65 has proven its superiority to FT8. Q65 handles interference better than FT8. FT8 will work on all the bands up to 5760, but Q65 works better. And this has been proven time and time again. On 2 meters, FT8 and Q65 work about the same. Same thing for 220 megahertz. 432, if you can't make it on FT8, go to Q65, you'll probably make it. We've seen that time and time again. Why, I don't know. I mean, there are people who work Q65 on HF, but the higher you go in frequency, the better it works. Probably has to do with frequency spreading. And if you use the audio frequencies I have listed there, you can get 5 QSOs into a single sideband passband. And we've had 4 people on 1296 at the same time, and 2304. 10 gigahertz. Now here's where it starts getting interesting. I have made contacts over a 200-foot path using FT8. Over a 30-mile path, even with very strong signals, FT8 will not work at all, whatsoever, 0. It just absolutely will not work. On 10 gigahertz, an FT8 signal, it doesn't look bad on the waterfall. It doesn't look a whole lot different from what you'd see on 40 meters. It doesn't sound bad, but it won't decode, at least here in Florida. It's probably due to water vapor, which causes water vapor causes multipathing, which causes frequency spreading. All I know is it doesn't work. I am told in drier climates it does work. I'm told in Europe it will work. Seems like some of the guys out in Arizona have made it work. On 10 gigahertz, we've used Q65 modes A, B, C, and D with 15, 30, and 60-second sequences with equal results over a 40-mile path. And if you want to work rain scatter, use mode C. That's really the end of my presentation. Just a little plug. Every Monday night we have WSJT night in the Southeast. People start getting on 144, 174 about 7 o'clock, somewhere along in there. I've made contacts as late as 10 p.m. Most of the participants are in Florida, Georgia, Alabama, the Carolinas. We've got 3 stations in Cuba that show up every now and then, the principal one being Radel, ES2, CO2 ESP, and even Eden's ZF1EJ shows up from time to time. We go up the bands, we go to Q65. A couple of Monday nights ago, I made contacts all the way up to 5760. And anyway, we have a good time. That's become automatic. A year and a half ago, if you wanted to take somebody to 1296, you usually had to specify what mode. It's become automatic now. If you go above 432 everybody knows to go to, if you're using Q6515A, to go to 170. Do have if you want to keep track of what we're doing here in Florida on VHF, we do have an email reflector, VHF Florida. It's one of the IO groups. And the way that we take people up the bands is we have a chat room provided by Jason, K4JMX up in EM90. No passwords required. Most of the time there'll be people logged into that a good bit of the time. Mostly in the mornings, there'll be anywhere from 2 to maybe 6 people logged in there. And if you want to take somebody up the bands, that's the way to do it. Rather than using the little, how many characters can you get into the FT8 text message? It's not very many, but you just get in the chat room and say, hey, let's go to 432 or let's go to 2304. And a lot of our activity here in Florida is in the mornings around, people get on starting around 6:30. The usual sequence is people get on 222 on around 6:30, then a little later on get on 432. The digital activity seems to start maybe a little, I don't know, I guess there's people get on as early as 6:30 on digital. I usually listen to code practice, and people I listen to on 80 meters for code practice at 7 o'clock, and I get on after that. And if the band's open to Texas, nobody in Texas gets home before 6:30 Texas time anyway. So that's what we do here in Florida, and always the more the merrier. Be happy to have any of you join us on the air. And that's all I got to say. And you can see some of my antennas, the 2 loop Yankees up top for 1296 and 2304, and my barbecue grill dish there for 5760. I thank you, and I've got a minute or two here for questions.
Did you have any correspondence with the San Bernardino County, California microwave group?
I see some of their posts occasionally on VHF contesting, but quite frankly, most of those guys they're up here and I'm down here. I ran into that. I gave a presentation at Microwave Update in Tucson back in the fall, and these guys will stand up there, and one guy had 2 PhDs. A lot of them were research scientists for the government or big companies, and yeah. So anyway, yeah. Anyway, yeah, I'm familiar with them. Another great group is the North Texas Microwave Society. I actually got a chance to speak in one of their Zoom meetings here a while. It was after we made those contacts across the Gulf on 5 gigahertz. I actually got to sit in on one of their Zoom meetings. Anyway, any other questions? Yeah.
So what kind of antenna would be the best for me to try this 2-meter Q65 with my little 828H? 30 element? What do I do?
You can buy an M-squared loop and just get it up above the eaves of your house and get on 144, 174. Now, that's not going to be easy with the 820. You're going to have to buy a external sound card, and that radio may not be stable enough. I'm not going to stand here and say that you got to have that, but if you look at somebody working FT8 or Q65 on 1296, and you just watch that thing, and then it goes that way, and then it goes that way. They're all over the place. And you can buy a GPS. They're not that expensive anymore. The first one I bought, I think I paid $300 for.
Now, what about on 144, 432? Is it as bad down there, or?
No, but I can look at a 9700 and tell you, even on 2 meters, if you got a GPS hooked to it.
I got you.
It's
The numbers you better get.
let me put it like this: if you buy a Bodner GPS and the Bodner board to swamp the oscillator, you just became a subsidiary of the National Institute of Standards and Technology. You're going to be so close that you're going to be within 1 hertz, even on 1296. GPS is pretty darn good. I set up my 9700 with the GPS as an IF for a DEMI transverter, which had GPS discipline, and then checked that against the 905, which got GPS built in, and I was within 1 hertz on 10 gigahertz. So yeah, it's like I said at the start, if you can buy a radio right out the box and get on 75 meters, and you're never going to have to touch it. But as you go up in frequency, it just gets a lot worse. Larry, I'm out of time. I thank you for your attention.
All right, microphone.